thank you all for coming tonight for this speech. I appreciate it. So, what is an automatic control system? An article from the Electronics Engineering website defines a control system as one which can monitor a variable of interest and correct it without human intervention whenever that variable goes outside of its desired value. And in this speech, I'll explain how to visualize the three major components that make up an automatic control system. And the central idea in this speech is to give you an understanding of the three major blocks: the comparison block, the compensation block, and the plant. But before I explain each of these three blocks of the control system, let's imagine that the control system that we're considering is a vehicle's cruise control system. That's an example that all of you should be pretty familiar with. So the first block, moving from a left to right fashion, is the comparison block. Comparison block has two signal inputs that are fed into the block. One of the signals is what's called the reference signal, and that represents the desired output of the system. And the second signal is actually the output of the system, which is fed back into the input where it's compared. So we call this a feedback signal because we're taking the output and feeding it back to the input of the system. So the comparison block compares these two signals, compares the reference signal to the output signal by doing a subtraction. It subtracts the output signal from the desired signal and gives you an error signal. So if the error signal is positive, that means that the system needs to increase its output. And if the error is negative, that means that the system needs to decrease its output in order to match what the desired position is. But if the input signal is exactly equal to the output signal, then the control system has done its job and it's corrected at 100%. So at that point, no further corrections are necessary. Now, once the error signal moves to the right, it encounters the compensation block. The purpose of the compensation block is to evaluate the error signal from the first block, the comparison block, and make an appropriate adjustment so that the output of the system reaches the desired value. Now, there are various types of compensation blocks in use in industry, but the most common type of compensation block is what's known as a PID compensation block. And PID stands for proportional, integral, and differential. So the compensation block essentially has three elements in it, where the compensation block has the proportional section, which looks at what the current value of the error is. It has the integral section, which looks at the present error as well as what the error has done in the past. And then it has the differential section, which makes predictions about what the error is likely to do in the future. So all three of these individual components make up the PID control system to provide the correct signal to the plant in order so that the plant's output becomes a desired value. So moving to the third block of the system, we have the plant. Now the plant is a part of the system whose output is actually being controlled. In this case, it's the speed of the vehicle that we're trying to control. And usually a plant consists of both electrical, and mechanical systems. It's usually not purely electrical or purely mechanical. And that's the case in our vehicle example. So the vehicle is, in this case, the plant, the vehicle, takes an actuation signal from the error block and it causes the vehicle's throttle to either increase or decrease based on whether the error is negative or whether it's positive. So the speed at which the plant can change its output when it needs to change has a lot to do with how the second block, the compensation block, has to be designed. If the compensation block is designed correctly, then the output will go to its desired value as quickly as it can, but without overshooting the value or undershooting the value. Now, one experiment you can do is you can take your car and go to 60 miles an hour, set the cruise, and then brake until you get down to 40, and then hit the resume button. What you'll see is that the compensator is going to give a large signal at first, but as it approaches its final value of 60, it starts to back off on the throttle so that you don't overshoot your final value. So tonight we've discussed the function of the three major blocks of the automatic control system. And understanding the function of the comparison, the compensation, and the plant is essential to having a basic understanding of what a control system is and how it works. So as I stated at the beginning of the speech, automatic control is required whenever we desire to eliminate or minimize human intervention in a process in order to control a desired variable. Thank you.
That was 5 minutes?
It did not mistake.
Really? That's good. That was 5 minutes.